So we have the work done. So the formula says W is the same thing as what? As P change in B. Change in B is the same thing as V2 minus V1. So this is the formula that you might use if you are asked to find what? To find work done, and you check a look to the question and see you are given the value of the initial volume and what? And the final volume. So you have to take note that P is what? P is the pressure. P is the pressure, and the pressure, the SI unit, which is Newton per meter square, or what? Or kilowatt, kilonewton per what? Per meter square. And you have to take note that W, which is work, stands for what? Stands for what? Work done. And work done is measured in what? In joule or kilojoule. So you have to take note of that. And we have V1, which is the same thing as what? As the initial volume. And we have V2, which is what? Which is the final volume. So you have to take note of what? Of this formula. And there is one thing that I need you to know. Expansion is what? Is the same thing as the positive work, and compression is the same thing as what? Negative work. Expansion is, let's say expansion let's say it is what? Let's say positive what? Positive work. And let's say compression. Compression is what? Negative work. So this is all for the work done formula. And also we have the heat transfer. So heat transfer, which is Q, is the same thing as what? MC delta T. So this is the formula that you might use if you are asked to find what? The heat transfer. Why the Q stands for what? For the heat, for heat transfer. And the SI unit, which is what? Joule or kilojoule. And also M stands for what? Mass in what? In kg. And we have the C, which is the specific heat capacity. Specific heat capacity. And this specific heat capacity SI unit, which is joule per kg Kelvin. And you have to notice that we have change in T, delta T, and this delta T is the same thing as what? As change in what? Change in temperature. And delta T is the same thing as what? T2 minus what? Minus T1, whereby we have what? The initial temperature and what? And the final temperature. We have the first law of thermodynamics formula, which is what? Which is the closed system. The closed system. So the formula says Q minus W, it is the same thing as what? E2 minus what? Minus E1. So this is the closed loop system, which is the first law of what? Of thermodynamics. And you have to take note that the Q stands for what? The heat supply to what? Supplied to system. And Y, W, which is the work done by what? By the system, which is the work done by what? By the system. And we have E1 and what? And E2, or E2 and what? E1. Now let's see the polytropic process formula. The polytropic process. So polytropic process formula, which is P1 V1 raised to the power of n, which is equals to V2 raised to the power of what? Raised to the power of n. So at this stage, you have to know that P1, which is what? Which is the initial pressure. Initial what? Initial pressure. And also P2, which is what? Which is the final pressure. And also V1, which is what? The initial volume. And also V2, which is what? Which is the final volume. And you have to take note that the n that you see here, the power of n, it is what? It is the polytropic index. The polytropic what? Index. And the common value of what? Of n, we have two ways. We have the isothermal process and we have the adiabatic process of what? Air. But in isothermal process, n, it is always equals to 1. But in adiabatic process for air, n, it is what? Equals to 1.4. You have to take note of that. The first one, which is for what? For the isothermal. For the isothermal process. But for the second part, which is what? The adiabatic process. So now we have the work done in polytropic process. We have work done, but in polytropic process, work done in what? In polytropic process, so the general formula for this work done in polytropic process is what? Is P2B2 minus what? Minus P1B1 divided by what? 1 minus the value of n. The value of n. So meaning, what this mean? This mean that we use this when pressure and volume change accordingly. What did I mean? When Pb raised to the power of n, it is equals to what? It is equals to constant. So don't forget with the general formula. So what I mean by that, we always use this formula when the value of Pb raised to the power of n is equals to constant is given. From the question, you might be given the value of maybe, let's say, the pressure 2 and the pressure 1 and pressure 2. So but you are asked to find the value of what? Of work done. So you can use the formula that says P1 B1 power n, which is equals to P2 B2 power, and as I explained from the first formula, so you can use this to find the value of what? The value of B2. After finding the value of B2, so you already find the value of B2. So in the next thing that you are going to do, from the question you might be given something like, let's say Phoebe, let's say power of 1.35, it is equals to constant. So you might be given this PB, it is PB raised to the power of 1 minus raised to the power of 1.35. We have the thermal efficiency. The thermal efficiency so the thermal efficiency formula, it is thermal efficiency which is equals to work by what? By Q. So this is the formula for the thermal efficiency. So the thermal efficiency, this stands as usual for what? For the thermal what? Thermal efficiency. This is efficiency, sorry. This is efficiency. And then the blue stand for what? The blue stand for what? The useful work output. So the useful work output. And the Q stands for what? The heat supplied. The heat what? Heat supplied. And to convert percentage, the thermal efficiency multiplied by what? By 100%, so that you will convert what? The thermal efficiency. What I mean by that is that at the end, if you have the value of this work and the value of this W, you have the value of useful work output and you have the value of heat supply. So you have to divide the useful output by what? By this heat supply. So after dividing it, the answer that you get, then multiply it by 100. So we have the mechanical power. The mechanical power, which is P, is the same thing as what? F multiplied by what? By speed. So you have to take note that the P stands for what? P stands for the power which is measured in what? The SI unit, which is what? Watts. And therefore the force, the capital force, which is what? Which is force or resistance. Force or resistance, which is in newtons. And you have to take note that this B is what? Is the velocity, which is what? Meter per second. And we have the general power formula. The general what? The general power formula. So the general power formula, which is power, is the same thing as what? As we all know, work done over what? Over the time taken. So this is the general formula for what? For the power, which is work done over what? Over the time taken. And the power is what? Is the rate of doing work. Power is the rate of doing work So this is the general formula for what? For the power. This is the what? This is the work done, and this is what? This is the time taking. And the definition of power. Power is what? Is the rate of doing work. Let's talk about the electric power formula. The electric power formula So the electric power formula, which is W is the same thing as what? As VI. This is the general formula for the electric power formula. So you have to take note that W is the same thing as what? Is the same thing as electric power in watts. And then V is what? Voltage. In volt. SI unit, which is volt. And therefore we have I, which is what? The current, which is measured, which is the SI unit as what? As ampere. And we have the potential energy, we have the potential energy formula, which is PE is the same thing as what? GZ. And you have to take note that this PE stands for what? Stands for potential energy per unit mass, which is potential energy per unit mass. And the G stands for what? The acceleration due to gravity. The acceleration due to gravity, as you all know, which is what? Which is 9.81 meter per second squared. And you have to take note that the Z, which is the height above the reference level, Z, which is what? Which is the height above the reference level, which is reference what? The reference level. So this is a potential energy formula that you might write it down, and it's very important. And also we have the kinetic energy. We have the kinetic energy. And the kinetic energy, KE, is the same thing as what? As C squared by what? By 2, which is the same thing as a half C squared. So this is what? Kinetic energy. You have to take note that the KE, which is kinetic energy per what? Per unit mass. KE is what? Kinetic energy. Let's say per unit mass. And also the C, which is the velocity of fluid. Velocity of what? Of fluid. So you have to take note of that. And also we have the flow work formula, or displacement work. The flow work, or what? Or displacement work. So the formula says work is the same thing as what? As P multiplied by what? The P multiplied by B. So whereby P is the same thing as what? As the pressure, and B as what? As the specific volume. Specific what? Specific volume. And also we have the dryness fraction of what? Of steam. The dryness fraction of steam, X, is the same thing as what? MS divided by also MS plus what? The MW. So this is the formula for what? For the dryness fraction of what? Of steam. But you have to take note that the X, which stands for what? The dryness fraction, the dryness fraction, and the MS stands for what? The mass of dry steam. The mass of what? Of dry steam. And the MW stands for what? The mass of water particle. Mass of the water particle. And you have to take note of something. You have to take note of something. X is equals to 1 at what? At dry saturated what? Steam. But X is what? Is less than 1 at wet steam. Less than 1 at what? At wet what? At wet steam. So this is all for the dryness fraction. We have the enthalpy of wet steam. Enthalpy of the wet steam. So the enthalpy of wet steam, which is H, is the same thing as what? HF plus X, the XH F what? FG. Meaning that, so you have to first take note, this is what? This is the formula of the enthalpy of wet steam. So this means that the H stands for what? For the total enthalpy of what? Of the wet steam. And the HF, it means the enthalpy of water. The enthalpy of water. And the H of Fg is the latent heat of what? Of vaporization. The latent heat of vaporization. Why what? The X, as usual, is the dryness fraction, and we all know the formula of dryness fraction. Dryness what? Fraction. So this is all for the enthalpy of what? Of wet steam. And also we have the enthalpy of dry saturated steam. The enthalpy of what? Of dry saturated steam. The formula of the enthalpy of dry saturated steam, which is Hg, is the same thing as H hot, HF plus HFG, meaning that the Hg, which stands for what? Which stands for the enthalpy of what? Of saturated steam. Yes, so this is for the enthalpy of what? Of dry saturated steam, And we have the superheated steam formula. We have the superheated steam. Also, the superheated steam, which is the H superheated, it is the same thing as H of F plus H of Fg plus the C P of S open bracket the T superheated minus T of S. So this is a formula for what? For the superheated what? Superheated steam. You have to take note that the H superheated, it stands for what? The total heat of superheated steam. The total heat of what? Of superheated steam. And the CPS is the same thing as the specific heat of superheat steam. The specific heat of superheated what? Steam. And the T sub also is the same thing as superheated what? Superheated temperature. And also the TS means the saturation temperature. The saturation what? Temperature. So this is all for what? For the superheated steam. And we have the degree of superheat. Degree of superheat. Degree of superheat. The degree of superheat is the same thing as, let me say, degree of superheat formula is the same thing as the T, the temperature superheated, minus the saturation what? Temperature. So this is the formula. So what this means? This means that the difference between the superheated temperature and what? Saturation of temperature. That is what the degree of superheat. The difference between the superheated temperature and the saturation what? Temperature. So we have the volume of wet steam. The volume of wet steam. Which is the V is the same thing as what? The dryness Vg plus what? Plus 1 minus the dryness fraction multiplied by P of F. So this is the volume of what? Of wet steam. Where the V stands for volume. Volume of what? Volume of wet steam. And the Vg, which stands for what? The specific volume of the dry steam. Specific volume of what? Of dry steam. Volume of water. So this is all for the volume of wet steam. So we have the ideal gas equation. Ideal gas equation, PB is equals to, whereby the P stands for the pressure and therefore the V stands for volume and the M stands for what? For the mass, and R stands for what? Gas constant, and T stands for what? The absolute temperature. which is in what? In Kelvin. And also we have the combined gas law, which says that the P1B1 over what? Over T1, which is equals to P2B2 over what? Over T2. So you have to take note of what? Of this formula. This formula used when gas change from what? From one state to another. So we have the partial pressure formula. The partial pressure, which is P, is the same thing as what? As the XIP total. So this is the partial pressure formula. So the P, sorry, this is PI. This is PI, which is the same thing as the partial pressure. The partial pressure, and whereby the XI is the same thing as what? The mole fraction. The mole what? The mole fraction. And also the P total, which is the same thing as the total pressure. So this is all I have for you for the first part formula of thermodynamics. Don't forget to subscribe to this YouTube channel so that you will be first person to be notified immediately if I uploaded a new content. You can check out the description of this video, whereby I pasted a link so that you will see the examples under these formulas. Don't forget to subscribe, press the bell icon so that you